What makes Earth different from every other planet we know? It isn't the biggest planet, it isn't the hottest, and it isn't even the closest planet to the Sun. Yet somehow, Earth became the perfect place for life. But why? What if just a few small changes in Earth's position, atmosphere, or temperature had been different? Would life have ever existed here? Let's find out. Earth wasn't designed around just one perfect condition. It is the combination of many conditions that makes our planet so extraordinary. So how did all of these pieces come together? And just how rare might a planet like Earth really be? Let's start with the most important factor of all: the right distance. Earth orbits the Sun at an incredibly important distance. Scientists call the region around a star where liquid water can potentially exist on a planet's surface the habitable zone. Move too close to the Sun, and temperatures can become extreme. Move too far away, and water can freeze. Earth sits within this zone, and that gives life one of its most important ingredients: liquid water. But being in the right location doesn't automatically make a planet habitable. Earth needed something more, something that could regulate its temperature: the atmosphere. Look up at the sky. It may appear empty, but surrounding Earth is a thin layer of gases that makes life possible. Our atmosphere helps regulate temperature, allows the water cycle to operate, and provides the gases living organisms depend on. It also contains the ozone layer, which absorbs much of the Sun's harmful ultraviolet radiation. Without this protective atmosphere, Earth's surface would be radically different. But even the atmosphere needs protection, and Earth has a hidden shield: the magnetic field. Deep beneath our feet, Earth's outer core contains moving molten metal. That movement generates a global magnetic field. We cannot see it, but it extends far beyond the atmosphere and interacts with the solar wind streaming from the Sun. This magnetic environment helps protect Earth from charged particles and helps reduce the loss of atmospheric gases to space. It's an invisible defense system surrounding the planet. And then, there's another object that may have played an important role in Earth's long-term stability: the Moon. The Moon. The Moon is more than something beautiful in the night sky. Its gravity drives ocean tides, and its presence helps stabilize the orientation of Earth's axis over long timescales. That matters because Earth's axial tilt influences the seasons and the distribution of sunlight across the planet. Without the Moon, Earth's long-term climate behavior could have been very different. But Earth still had another challenge to solve. It needed to regulate itself. A living, moving planet.
Earth isn't a motionless rock. Its tectonic plates are constantly moving. They build mountains, trigger earthquakes, create volcanoes, and recycle material between Earth's surface and interior. These processes are connected to the long-term carbon cycle. Carbon moves between rocks, oceans, atmosphere, and living organisms. Over enormous periods of time, this helps influence Earth's climate. In other words, Earth has natural systems that constantly interact with one another. And then came one of the most extraordinary developments of all: life itself. The chemistry of life. Life needs the right ingredients: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. These elements are found throughout Earth. They combine in countless ways to form the molecules that make living organisms possible. But the story doesn't end there, because once life appeared, life began changing the planet.
When life changed Earth, early photosynthetic organisms released oxygen into the atmosphere. Over immense periods of time, oxygen levels rose. That transformed Earth's environment and helped create conditions in which more complex life could evolve. Plants, microorganisms, animals, oceans, and the atmosphere now form an enormous, interconnected system. Earth didn't simply provide a place for life. Life became part of Earth's planetary system. And perhaps that's the most fascinating part of the story. The big picture. Think about everything that had to work together. Earth needed a suitable distance from the sun. It needed stable sources of liquid water. It needed an atmosphere capable of regulating temperature. It needed protection from solar radiation. It needed the right chemical ingredients. And it needed long periods of geological stability mixed with constant change. None of these things alone explains life. Together, they created an environment where life could not only appear, but survive, adapt, and evolve for billions of years. And that leads to a much bigger question.
If Earth became habitable through such a remarkable combination of conditions, how many other planets in the universe might have the same combination? We have discovered thousands of planets beyond our solar system. Some orbit at distances where liquid water might be possible. But so far, Earth remains the only world we know for certain to have life. So perhaps the most extraordinary thing about Earth isn't that it's a planet. It's that somehow, out of all the possibilities in the universe, this planet became a home for life. And somewhere out there, another Earth might be waiting to be discovered. This is Earth Untold.